and their applications. Their applications. So this is chapter 1, chapter 2, chapter 3, chapter 4, 5, and then last is chapter 6 is digital electronics. ठीक है? So we are going to cover these 6 chapters in electronics. So as I have told you, first lecture is the introductory lecture. So we will introduce the basic concepts. So let's see detailed syllabus for network analysis. Chapter 1, topic 1 is network analysis. Network analysis. So first you should know what is Kirchhoff's voltage law. Kirchhoff's current and voltage law. Current and voltage law. शॉर्ट में क्या बोलते हैं इसको? KCL एंड KVL. Kirchhoff's current law and Kirchhoff's voltage law. ठीक है? Then we have network theorems. Network theorems. First is superposition theorem. Superposition theorem. Whenever there is more than one source, we can use superposition theorem to write the voltage and current. ठीक है? Next is Thevenin's theorem. Thevenin's theorem. Then we will talk about Norton's theorem. And we will talk about maximum power transfer theorem. Maximum power transfer theorem. We will also talk about Wheatstone bridge. You must know about Wheatstone bridge. ठीक है? Wheatstone bridge. So this is the introductory lecture. Without basic concepts, you will not be able to understand different topics in electronics. ठीक है? So the first lecture is introductory lecture. Is it clear?
Yes, sir.
So note it down. Note कर लिया?
Yes, sir.
Okay. So हाँ, okay.
Okay, sir.
Okay. Now, what are the elements that we will use in electronics? What are the elements? So we define two types of elements. One is called as, in terms of electronics, we talk it as a active element and passive element. ठीक है? So what is a passive element? Active element is, so that are capable of delivering energy independently for a very long duration of time. When a particular element delivers energy independently for very long time, that element is active element. For example, if you have some voltage source, you have a current source, if you have a transistor, operational amplifier, so those elements are called as active elements. Okay? So you should write what is an active element. So active elements are capable of just left some space here because we have to write other active elements also, independent, dependent. So active elements are capable of delivering energy independently for a very long, you can call it as, when I say infinite or very long duration of time. Duration of time. ठीक है? Examples are voltage source, like voltage source, current source. ठीक है? Transistors, operational amplifier. And what are the passive elements? So passive elements are not capable of delivering energy independently for very long duration of time. So only thing it is not capable of delivering energy. So you can write the passive element also. So passive elements are not capable of delivering energy independently for a very long duration of time. So this they may not deliver, or if they deliver, they will deliver for finite time. For example, if you have a capacitor, if it is initially, it has some voltage, so during some time that capacitor will be discharged. Or if you have an inductor, if it stores some energy, it may discharge. So passive elements are R, L, and C. So you will encounter, we will talk about only these elements. Active elements in a circuit, we have either active element or passive elements. ठीक है? Now active element, active source, we again categorize it as a independent, independent, independent and dependent source. Dependent source. Now independent source are voltage and current. Voltage source and current source. You have a voltage source and you have a current source. Again, we will talk about ideal voltage source and practical voltage source. Ideal and practical voltage and current sources. So we will talk about ideal and practical voltage and current sources. So we will talk about independent sources, but there are dependent sources also. There are dependent sources also, and we can design it using independent. So this is called as, one is called as voltage controlled voltage source. This is VCVS, means voltage controlled voltage source. Then you have voltage controlled current source. Voltage controlled current source. Then you have current controlled current source. Current controlled current source. And then you have current controlled voltage source. Current controlled voltage source. So that is how in electronics we encounter these elements only. Yes or no? ठीक है?
Yes.
We will also encounter different terms like what are bidirectional element. There are bidirectional element. Bidirectional element. Bidirectional element means by changing the direction or polarity, property of the element will not change. It will conduct in both direction. So current can flow left to right or right to left. So that are the bidirectional element. There are unidirectional element also, like diode. This is like resistor, unidirectional element. So we will encounter these terms also, bidirectional, unidirectional. Then you have linear elements. Linear elements where current is proportional to, or voltage is current proportional to current. You have non-linear elements also. So voltage is not linear to current. ठीक है? Is it clear? Yes or no?
Yes, sir.
Yes, sir.
So I have just given you what types of element you will encounter during the study of electronics. So that is the classification. Clear? So now I will introduce what is ideal and practical voltage and current sources. By definition, what is the voltage and current source? So can I take next slide?
Yes, sir.
Yes, sir.
Okay. So first we will talk about ideal and practical voltage source. and practical voltage sources. Ideal and practical voltage source. So let's see what is the ideal voltage source. So I'm taking, consider this to be a some voltage source. Let's say this is by Vs, and this is delivering energy to some load. Load may be anything. So this is delivering. So what will be this voltage? Let's say this current is I. So what will be voltage across this? This voltage is equal to Vs. है कि नहीं? I will talk about KVL. So because there is no drop across it, you know that. Let's see if there is a resistance R in which current I is flowing, what will be voltage across it? Voltage is given by V is equal to I into R. Yes or no?
Yes, sir.
Yes,
So,
sir.
and there is only this particular voltage source. There is no other drop. So this drop will be across load resistance also. And this load is variable. This load is variable. So this is the ideal situation where, just see, if you plot V versus I, if you vary load, current will change. If you vary load, current will change. Yes or no? So you should, what will be current I? Current I is given by V by RL here. So when you vary load, current will change, but voltage across load will not change. है कि नहीं? आप कोई भी लोड रखो क्योंकि और कहीं ड्रॉप नहीं है, सो दिस ड्रॉप विल बी अक्रॉस लोड ओनली. तो आइडियली क्या हो गया? अगर आप आइडियली प्लॉट करो V वर्सेस I, V क्या है? वोल्टेज ड्रॉप अक्रॉस लोड. व्हाट इज V? V इज voltage across load. V is voltage across load. Load means that can vary, and I is current through load. Current through load. ठीक है? अब देखो, इस एक्सिस पे हमने I प्लॉट किया और इधर V प्लॉट किया. तो अगर करंट चेंज करोगे, सो व्हाट विल बी वोल्टेज अक्रॉस लोड? ये चेंज होगा या नहीं होगा?
वेरी करेंगे सर.
नो, इट विल रिमेन कांस्टेंट.
वोल्टेज.
वोल्टेज की वैल्यू हमेशा लोड पे VS ही होगी. चेक कर लो भाई, ये ड्रॉप तो और
Yes,
कोई
sir.
नहीं है. जो भी ड्रॉप होगा वो इसके अक्रॉस होगा. ठीक है?
Voltage sir, remains constant if the current and the load is variable.
If load is varying, although load is varying, current is changing, but voltage across load is fixed. So that is the ideal situation. This is called the
Yes, sir.
ideal voltage source. ठीक है?
Understand.
Clear? So what is an ideal voltage source? You should write an ideal voltage source, an ideal voltage source has zero internal resistance. Zero internal resistance. और ये रेजिस्टेंस सीरीज रेजिस्टेंस होता है. मतलब आपको एज्यूम करना है इन अ वोल्टेज सोर्स देयर इज अ जीरो इंटरनल सीरीज रेजिस्टेंस। हमेशा वोल्टेज सोर्स के साथ सीरीज रेजिस्टेंस होता है, ठीक है। हैज जीरो इंटरनल सीरीज रेजिस्टेंस एंड it delivers energy at a specified voltage that does not depend that does not depend on the current on the current on the current delivered by the source, current delivered by the source. Source is delivering which this current I. Current through the load is I, and that is the source current. In this case, this is the source current. So whenever you have a voltage source, ideal voltage source, its internal resistance is 0 and voltage across the load is independent of the current delivered by the source. Is it clear? This is the ideal situation. ठीक है? Yes or no?
Yes, sir.
Now
Yes,
what
sir.
will happen in practical situation? Just see, practical situation, there is a very small series internal series resistance. So if you, this is for ideal case. Now let's draw for practical case. In a practical situation, this is Vs. Now there is a very low series resistance. Let's call it as Rs. Rs is the series resistance. And this is the load. Load resistance RL. This is V. So what will be this current? Current is I. So there will be voltage drop across this I into Rs. So voltage V is given by what? Vs minus I into Rs. Yes or no? अब देखो क्या होगा? If there is a, that's why in a practical situation, there is a very small series resistance Rs. So when it delivers energy, current delivered by it is I. So there will be some drop across this. So this voltage will be slightly less than this value. Yes or no? And if current keeps on increasing, voltage will keeps on decreasing. So that is the practical situation. ठीक है? Is it clear?
Yes, sir.
So this is the situation where Vs is constant. This situation is when Rs is 0. This is the ideal situation. And what will be practically? Because just see, when current is increasing, voltage is when current increases, voltage will decrease. So this voltage will keep on decreasing. Yes or no?
Yes, sir.
This is the ideal situation और ये practical situation है. ठीक है? So it means what? You cannot draw any amount of current from a voltage source because एक पॉइंट के बाद ये सारा ड्रॉप इसके अक्रॉस हो जाएगा एंड यू विल गेट 0 वोल्ट अक्रॉस दिस. ये दिस इज द प्रैक्टिकल प्रॉब्लम है कि नहीं? तो इस प्रैक्टिकल सिचुएशन को अवॉइड करने के लिए हम क्या करते हैं? दिस आर एस शुड बी एज स्मॉल एज पॉसिबल सो दैट दिस ड्रॉप इज वेरी स्मॉल. ये ड्रॉप जितना स्मॉल होगा वोल्टेज विल बी क्लोज टू Vs. इज इट क्लियर?
Yes, sir.
Here,
Yes,
which
sir.
one is variable, sir? RS or RL?
Which one?
Which one is variable?
No. This is the source resistance. RL
This is
load is
load.
always variable.
Oh, okay, sir.
RS is the internal source resistance. This is fixed value. For a
Okay.
given source, RS is some fixed value, very small finite value. Ideally, just see, ideally source resistance is 0. That's what
Okay.
the ideal source. So RS is source resistance. And this is very small. Clear? Load
Okay.
is variable.
Clear, sir. Thank you, sir.
So now write down about practical source. So practical voltage source. Practical voltage source has very small internal resistance, internal series resistance, RS, and it delivers energy. It delivers energy at a specified voltage, which depends on the current delivered by the source. Current delivered by the source, which depends on the current delivered by the source. Clear? So, we will discuss this problem is also called as loading effect, because when you are connecting some voltage source across a load, you are not getting this voltage close to Vs. This drop will be across its source resistance itself. So we have to avoid the loading effect. How you should avoid the loading effect? One thing is that this current is, you are drawing very small amount of current, or if current is very large, RS should be very small. And another thing is, we will talk about buffer circuit. So we will talk about buffer, common collector as a buffer circuit, operational amplifier as a buffer circuit. So we can use a buffer circuit to avoid this loading problem. ठीक है, वो हम discuss करेंगे. But you should know this is the problem that we face. Although you have applied Vs for but one particular row RL, voltage across this will be almost 0. Yes or no? Because you are drawing different amount of current for different load. है कि नहीं? Why current is changing? Because load is varying. आप load vary करोगे तो current change होगा. ठीक है? Yes or no?
Yes, sir.
So you should note one point here, that we cannot draw any amount of current, I from source because for higher values of I, voltage across load will reduce to 0. reduce to 0. ठीक है? Is it clear? So this is the ideal and practical voltage sources. Clear?
Yes,
Note
sir.
it down. Can I take next slide?
Yes, sir. Yes.
Sir,
ठीक है?
voltage across the load means VS. Voltage across the load is
No, no.
if the current is increases.
If current
Yeah.
is increasing, voltage across load is V, and this V is what? Vs minus I into Rs. So that's why voltage across load is changing. देखो, what is our purpose? Our purpose is you want to supply some source, some voltage to some external load. कोई भी load को आपको voltage supply करना है. So ideal thing is if you have applied Vs, we want that this voltage should be Vs. यही तो हमारा purpose है ना? जो voltage apply कर रहे हो वही voltage मिले. Yes or no?
Yes, sir.
So when you have ideal situation, there is no series resistance that is possible. But practically, that is not the case. Practically, there will be some source resistance. So if you apply same voltage to different load, you will get different amount of voltage across this. This will be Vs minus IRs. अगर I की वैल्यू बहुत स्मॉल है, then V is close to Vs. तब कोई प्रॉब्लम नहीं है. जब I की वैल्यू बहुत स्मॉल है तो ऑलमोस्ट क्लोज है. बट वेन आई इज कीप ऑन इंक्रीजिंग, कब इंक्रीज करेगा? जब लोड को आप डिक्रीज कर रहे हो. सो लोड इट विल कीप ऑन इंक्रीजिंग, और एक पर्टिकुलर वैल्यू पे वो जीरो भी हो सकता है.
Load means decreases means that load resistance decreases.
Yes, load means load resistance is decreases. Yes.
Sir, that time and that situation, what is the purpose of the RS?
No, this RS is fixed. This is along with source resistance. You can't change this. When you design some voltage source, there will be some fixed source resistance. So what is the voltage source? This particular part is the voltage source. You can't change RS resistance, RS value. हमें जो voltage मिल रहा है, voltage source that you are getting, it has Vs and you have RS. This is your voltage source. You can't change it. और हमें करना क्या है? You want to apply this to some load. Load आपको decide करना है कि कहाँ apply करना है कि नहीं?
So we are purpose that the V equals to Vs.
That's what our purpose is.
Okay, sir.
Clear? So that's why this will create problem. And there are different way of avoiding this. I have told you either you should take a smaller value of current, or RS is close to 0. If it is not possible, then you will see we will talk about buffer amplifier. Even if this value is very large, current is very large, even then we can use a buffer in between RL and source, and you can avoid this problem. ठीक है?
Sir, but
Okay, sir.
I is controlled by RL. I is controlled by RL.
RL plus RS, but देखो अब I की वैल्यू क्या होगी यहाँ पे?
RS is constant ना.
RS is fixed value. You can't change RS. जो भी एक
Okay,
सोर्स होगा उसका फिक्स्ड RS है.
We are varying RL.
RL वैल्यू करोगे तो करंट तो वैल्यू होगा ना, VS बाई RS प्लस RL.
Yes, sir.
करंट की वैल्यू अगर आप लिखो तो क्या लिखोगे? VS बाई RS प्लस RL. अब मान लो मैंने ये कर लिया, ये फिक्स है, ये फिक्स है, ये वैरी कर रहा है, तो इसके वैरी करने से करंट नहीं होगा चेंज.
Yes.
ठीक है? तो लोड तो हमेशा, जब मैं कह रहा हूं लोड कुछ भी हो सकता है. कुछ भी का मतलब उसकी रेजिस्टेंस कुछ भी हो सकता है. एनी लोड. ठीक है?
So to reduce current, we can increase RL.
Yes, by reducing RL means you can take lower load resistance, you can take higher value of. So at higher value of RL, this problem will not arise. अगर मैं सपोज RS को ओम्स में ले रहा हूं और RL को किलो ओम्स में ले रहा हूं, तब ये और किलो ओम्स और मेगा ओम्स ऑर्डर में ले रहा हूं, then this problem will not arise because then current will be very small. है कि नहीं? तो वो डिपेंड करता है किस करंट वैल्यू के लिए. यहां पे हो तो ये इससे क्लोज है, जैसे जैसे आप करंट की वैल्यू बढ़ाओगे वोल्टेज इज डिक्रीजिंग. क्लियर? यस और नो?
Yes,
ठीक है?
sir.
Yes, sir.
Okay. Now let's see what is ideal and practical current source. You have ideal and practical current source. Ideal and practical current source. Now, current source have parallel resistance and in ideal situation it has infinite parallel resistance. तो पहले हम practical ideal current source की बात कर रहे हैं. Let's see ideal current source. तो आइडियल करंट सोर्स की क्या सिचुएशन होगी? मान लो मैंने ये करंट एज्यूम कर लिया. लेट्स से दिस करंट इज IS. हम करंट सोर्स को इस सिंबल से रिप्रेजेंट कर रहे हैं. ठीक है? और यहां पे हमने नाउ सी open circuit means what? This is open circuit situation. So whenever you have open circuit, ये पॉइंट नोट कर लो आप. ओपन सर्किट का क्या मतलब है? What will be resistance? शॉर्ट में हम बोलेंगे ओपन सर्किट. ओपन सर्किट मींस इनफाइनाइट रेजिस्टेंस. इनफाइनाइट रेजिस्टेंस. ठीक है? और क्लोज सर्किट का क्या मतलब है? उन दो पॉइंट्स में अगर किन्हीं दो पॉइंट्स को आपने क्लोज कर दिया, क्लोज सर्किट. क्लोज सर्किट इसका मतलब है जीरो रेजिस्टेंस. दिस पॉइंट इज क्लियर? तो यहां पे देखो ये क्या है? ओपन सर्किट कंडीशन है. सो इट हैज इनफाइनाइट रेजिस्टेंस और ये करंट IS है. और फिर से हमने यहां पे एक लोड को कनेक्ट कर दिया, वेरिएबल लोड को. ठीक? सो लेट्स से दिस करंट इज I and this current is I1. Because this is open circuited, ये open circuit है, infinite resistance है, this current will be zero. So this current I is IS. Yes or no? और ये सेम करंट यहां भी फ्लो होगा. And what will be this drop? Voltage across this will be V. ठीक है? V is the voltage drop across load. And that is because this parallel voltages are same. ये इन दो पॉइंट्स के बीच का जो वोल्टेज होगा दैट इज V and that is same as voltage across the source. है कि नहीं? Parallel voltages are same. In series, current will be same. In parallel, these are basic thing you should know. In parallel, voltage is same. Voltage is same. And in series, current is same. ठीक है? So it means this is the current and what is the, if you plot I versus V, current through the load and this voltage across load, इस सिचुएशन में क्या होगा? I versus V. V is the voltage across load or voltage across the source. So what if you vary V? V की वैल्यू क्या होगी? I into RL. और अगर RL को वैरी करोगे then voltage will change, है कि नहीं? Because this I is equal V is equal to then IS into RL. और IS की fixed value है. So if you keep on increasing RL, V will increase. But what will be current? Current delivered by the source? बोलो.
Constant.
Constant value. So this current will not change. This value is IS. This is the ideal situation. I am taking this parallel resistance is infinite. ठीक है? Clear? No issue doubt. Can I erase it?
Yes, sir.
Yes, sir.
Yes, sir.
Now write down about ideal current source. So an ideal current source has an infinite parallel resistance. Infinite parallel resistance. Have infinite parallel, we call it as internal resistance. Parallel internal resistance. And it delivers energy at a specified current which does not depend on the voltage across source. Because parallel voltage is same, so this voltage is same, this voltage is also same. This voltage is V, voltage across the source. Is it clear? So this is the ideal situation. But in reality, in practical case, what will happen? There is a very large parallel resistance. So this is RS. There is this is RP, parallel resistance here. And then you have a load RL here, variable load. This is the parallel resistance. This current is IS. This current is I1 and this current is I. And what will be voltage across it? This is V. And this voltage is also V. Okay. So we will talk about current division rule. So, but you should note it here that in this situation, this IS is equal to I1 plus I. So this I will be given by IS minus I1. ठीक है, और I1 की वैल्यू क्या होगी, वोल्टेज अक्रॉस दिस डिवाइडेड बाय आरपी. तो ये क्या हो जाएगा, देखो IS इज V by RP. So if V increases, अगर V की वैल्यू इंक्रीज होगी तो क्या होगा, करंट की वैल्यू डिक्रीज होगी, है कि नहीं?
Yes, sir.
So in this situation, if you plot I versus V, ये आइडियल सिचुएशन है IS, और IS में RP की वैल्यू आपने क्या लिया हुआ है, इनफाइनाइट. RP is infinite. So now in this case, you will get this particular plot. ठीक है? So a practical current source has very large parallel internal resistance RP, and it delivers energy at a specified current, at a specified current which is dependent on the voltage across the source. Voltage across the source. ठीक है? So that's why just see why we want very high value of RP, so that I1 is almost zero. When I1 is almost zero, I is equal to IS. So in current source, our purpose is that across the load current should be equal to the IS. And that is possible when RP is very large, although there is a voltage variation. But when RP tends to infinity, these values are very close. So these are the ideal and practical voltage and current source. Is it clear? Yes or no?
Yes, sir.
Note it down. Can I take next slide?
Yes, sir.
Okay. Now let's see some, you should decide what is node, loop, and branch. So let's draw a circuit here. Let's say this is some voltage source, and we have some resistance So this is some source Vs. This resistance is R1, this is R2, and this is R3. So these are the different elements. So let's say one element is this, another element is this, this is another element, this is another element. So there are different elements in this circuit. Vs, R1, R2, R3, they are elements. So when two or more elements are connected, then their common point is called as node. Just see, this is one element, this is another. So this is one node. Now this is one element, this is another element, this is another element. So this common point is another node. Okay? So node, what is a node? When two or more elements are connected together, when two or more elements are connected together, then the common point is called a node. So these are the different nodes. These are the different nodes. ठीक है? Now you should further differentiate what is a simple node.
In the first case, which is R1 VS.
R1 and Vs. They are different elements, and when their elements are connected together, their common point is called as node.
The first case, which one is common point, sir?
So this is one element, this is another element, this is common point. When you are considering this and this, so this is the common point. Just see which element you are talking about, two element or more than two element. So at this junction, there are 1, 2, 3. This is the common point. है कि
Yes,
नहीं?
sir.
So let's see. This is the one. Let's call it as N1. So these points are same. Let's call it as N2. Let's call it as N3. N3 ये सारे same ही point है. Yes or no?
Yes, sir.
So these are the nodes where two or more than two elements are connected. So when you will call simple node, when two elements are connected together. When two elements are connected together. Example is N2. N2 is a simple node, and here ठीक है? So there will be, they are in series. Now you have a principal node. Principal node. When more than two elements are connected together. When more than two elements are connected together. ठीक है? For example, you have N1 and N3. They are the principal node. N1 and N3 are the principal node. What is a loop? When starting and ending node of a path is same, then that is called as loop. For example, let's say this is the starting, you have started with here and then you should end here. So this is one loop. Let's say you have started with here and then you have ended at that point. This is second loop. So when you have started from a particular point and then you have ended at the same point, so that path is called as loop. And branch or element are same thing. It is a single path. It is a single path that is one element with node at each end. Node at each end. Okay? So you should know these points. Clear?
Yes, sir.
Now we will see KVL and KCL. This first lecture is introductory lecture. I am just giving you the basic points. Can I take KVL, KCL?
Yes, sir.
Okay. So now let's talk about Kirchhoff's current law.
Can you please leave this slide? Thank you, sir.
Okay. Kirchhoff's current law. In short, call it as KCL. So let's see, we have different resistance, different elements, they are connected at a node. R1, R2, R3, R4, R5 and R6, and this is the node here. Assume this current is I1, this current is I2, and this current is I3, this current is I4, this current is I5, and this current is I6. So I have shown the direction of currents. Let's see, this is the direction of I1, I2. This is the direction of I3. These are the direction of current in different. So at any node, according to Kirchhoff's, the algebraic sum of current entering any node is 0. Algebraic sum means you have to consider the sign also, plus and minus, whether current is entering the node or current is leaving the node. So according to KCL, the algebraic sum of current entering any node is 0. So when you have to see algebraic sum, you have to take some sign convention. So let's see, current entering the node is positive. Entering current, I am taking to be positive. And leaving current is negative, leaving the node. Current is negative. Okay. So let's start with I1. So this is I1 plus I2. Leaving current is minus I3 plus minus I4. Then you have plus I5 plus minus I6. This will be 0. Yes or no?
Yes, sir.
So this will give you I1 plus I2 plus I5. This will be equal to I3 plus I4 plus I6. So this will be sum of entering current is equal to sum of leaving current. Sum of entering current and sum of leaving current. And this is based on the principle of conservation of charges. This is based on the principle of conservation of charges. So any node cannot generate, destroy, or store the charges. Whatever be the charges that are coming, that same charge will going out. So it is based on the principle of conservation of charges. Is it clear? What is KCL?
Yes, sir.
Yes, sir.
So note it down. Can I take next slide?
Yes, sir.
Sir, 1 second.
Yes, yes, yes. Please. ठीक है?
Yes, sir.
Then you have Kirchhoff's voltage law. In short, we call it as KVL. Let's see, this is some voltage source V. This is R. And this is RL. Assume in this current is I. I'm showing the polarity. Current flows from high potential to low potential. This is negative. This is positive. And let's consider this loop. It's a closed loop. This is a closed loop. If you start with this point, then you should end at this point. So, according to KVL, the algebraic sum of voltage in any closed loop is 0. In any closed loop is 0. So again, there is algebraic sum, means there is some sign convention involved. So sign convention, you have to decide. For example, if you are going from minus to plus, if you are taking minus sign, then whenever you are going from plus to minus in an element, you have to take minus sign. This is minus, then you have to take plus. So if you see the algebraic sum, let's start with voltage source. So first I am taking minus V, then plus I am taking R plus I into RL. This will be 0. Or you can take otherwise also. If you are taking this as a plus, then you have to take it as minus. So this sign convention will not change the result. You have to decide whether you want to take this convention or this convention, because they will give you same result. And current will be given by what? V by R plus RL. Is it clear? Both will give you same result. Okay?
Yes, sir.
So you can take either this convention or this convention. So I will take this particular convention, so that when you are encountering minus to plus, take minus sign, plus to minus, plus sign. Okay? So this is the current in the circuit. And what will be voltage drop across R? What will be voltage drop across R? This is given as I into R. So this is VR by R plus RL. What is voltage drop across RL? I into RL. So this is given by VRL by R plus RL. You can remember this as a current division rule. Current division rule. Okay? Just see, if two resistances are in series, you can directly find what will be this voltage. V into R by R plus RL. What is this voltage? V into RL by R plus RL. So sometimes you will see we will directly use this result. Is it clear what is current division rule?
Yes, sir.
So we will directly use current division rule. Similarly, this is voltage, not current division. This is voltage division. We are dividing voltage, no? So it's a voltage division rule. Voltage is dividing. We can also have current division rule.
सर VR क्या हुआ सर?
V into R. I is what? V R by R. So I into R is V into R by R plus RL.
VR और VRL इसमें डिफरेंस सर.
VR is voltage across R resistance. Voltage across RL. इसमें कोई confusion है?
No sir. Okay, thank you sir.
So what is voltage across R? Current through R into R. What is voltage across RL? Current through RL into RL. What is current division rule? We will directly use these results. So you must remember it. What is voltage division rule? What is current division rule? So in current division rule, consider this current is I, and this current is dividing between two parallel resistance. R1, R2. This current is I1 and this current is I2. This current will be I. So at this node, let's say this point is 1, this point is 2. So at node 1 and 2, at both nodes, I is I1 plus I2. Yes or no? And parallel voltages are same. So what is voltage drop across 1, 2? This will be same as I1 R1, and that is same as I2 into R2. Voltage drop between 1 and 2 will be same. Parallel voltages are same. है कि नहीं? ठीक है? Now solve 1 and 2. Solve 1 and 2. So what will be I1 and I2? I1 will be, if you solve it, you will get R1 in R2 into I. Let's check. R2 into I by R1 plus R2. Please check this. And what will be I2? R1 into I by R1 plus R2. ठीक है? Just simplify it. So this is called as current division rule. What is current division rule? If two resistances are in parallel and current I is dividing between R1 and R2, then current through R1 will be, I1 will be what? Simply R2 into I by R1, I1 plus I2. And what will be current through I2? This is R1 into I by R1 plus R2. Yes or no? ठीक है?
Yes, sir.
So this is the current division, voltage division rule, and this is current division rule. Now we can apply KVL and KCL in more than one loops also. Can I take next example?
Yes, sir.
Now take a two loop network. This is 12 volt. This is 3 ohm, 6 ohm, 7 ohm, and this is also a 7 ohm. Okay? Take this current is I1. This current is I2. So this current will be also I2. So according to KCL, what will be this current? Bolo? So this current will be I1 minus I2. Yes or no? And now show the polarity. So we have to find I1 and I2. So we need two loops, loop 1 and loop 2, and apply KVL in these two loops and solve for I1 and I2. See, loop 1. So minus 12 volt plus 3 I1 plus 6 I1 minus I2 is 0. So this will give you 9 I1 minus 6 I2 is 12. Equation 1. Loop 2. 7 I2 plus 7 I2 minus 6 I1 minus I2. This will be 0. So what will be this value? So minus 6 I1 plus 8 I2, 7 plus 7, 7 I2 plus 7 I2 minus 6 I1 minus I2. So this is minus 6 plus 20 I2 is equal to 0. So 3 I1 is 10 I2. Now solve 1 and 2. Solve 1 and 2. You will get current through each element. Let's solve 1 and 2. What will be the value of I1 and I2? Bolo. What will be I1 and I2?
So I1 is 5 by 3 ampere
I1
and
is
5
no.
by 3.
Okay, 5 by 3. And what will be I2?
1 by 2.
So what will be I1 minus I2? क्या हो जाएगा?
7/6.
7/6 ampere. Yes or no?
Yes, sir.
So just see, by applying KVL, you have calculated current through each element. This 6 ohm is I1 minus I2. So this current is 7/6. So by applying KVL, KVL and KCL, you will get the current. And if you know current, you know the voltage across different element. ठीक है?
Yes, sir.
Now try to solve this question from current division rule. Let's solve this using current division rule. ठीक है? इसको try करना using current division rule. So in next lecture, I will discuss how to solve it using current division rule. And then we will take KVL example with more than one source. And after that, we will talk about the superposition. Okay? So any doubt in today's lecture?
Sir,
No, sir.
please, third slide.
Sir,
ठीक है?
last
हाँ.
slide also.
हो गया ये? Third slide?
The last slide.
समझ में आ रहा है सबको?
Yes, sir.
नोट्स प्रिपेयर कर पा रहे हो या नहीं?
Yes, sir.
यू शुड प्रिपेयर योर ओन नोट्स, क्योंकि एग्जाम में अब आपको दोबारा वीडियो नहीं देखना है, बाकी कुछ नहीं करना है. जो आप नोट्स प्रिपेयर कर रहे हो उसी को रिवाइज करना है. सो यू हैव टू कंप्लीट योर ओन नोट्स. आप अपने नोट से रिवाइज करोगे तो चीजें याद रहेंगी. ठीक है?
Sir, fourth slide.
फोर्थ स्लाइड.
Sir, thermodynamics में thermal physics वाला section वाला.
हाँ, वो फ्राइडे सैटरडे है क्लासेस.
Okay, sir. Thank you.
Okay, sir. Thank
वी विल
you.
टेक ऑन फ्राइडे एंड सैटरडे, वी विल टेक थर्मल क्लासेस ऑल्सो. ठीक है? ठीक है?
Sir, और weekly test हमारे कब से start होंगे?
अब इलेक्ट्रॉनिक्स से आपके स्टार्ट करेंगे. अभी थर्मल के नहीं हुए ना, इलेक्ट्रॉनिक्स के स्टार्ट होंगे. जब नेटवर्क हो जाएगा तो इसका टेस्ट हो जाएगा फिर आपका.
Sir, thermal complete हो गया?
नहीं, अभी थर्मल के 2-3 लेक्चर हैं, इसके बाद फिर स्टैटिस्टिकल स्टार्ट होगा. वो फ्राइडे सैटरडे चलेंगी क्लासेस. ठीक है?
Okay, sir. Thank you.
Sir, EMT?
नहीं, वो अब एक बार सारा एक साथ स्टार्ट कर दें.
Okay, sir.
भाई 1 by 1 करो ना. आपको सीखना भी तो है कि
सर
सारा
अभी तो सर EMT का वीकली टेस्ट हो रहा है सर.
अभी जो पीछे लेक्चर हुए हैं उनके टेस्ट जो नहीं हुए हैं वो हो जाएंगे, या कुछ 2-4 लेक्चर अभी पेंडिंग है वो मैं ले लूंगा.
ना
और
सर
फ्रेश
20 जून का जो स्टार्ट हुआ है
हाँ,
क्लास.
उसके कुछ लेक्चर हैं अभी मैं लूंगा वो. और फ्रेश बैच जो है उनके फिर आई थिंक अक्टूबर से स्टार्ट होंगे. देखो मैं एट ए टाइम 2 टॉपिक ले सकता हूं, उसके बाद फिर नेक्स्ट टॉपिक लूंगा.
वीकली टेस्ट जो 20 जून से कर रहा है
वो
उसके
उनका
लिए.
ईएमटी का होगा टेस्ट. और
अच्छा,
फिर अब ये इलेक्ट्रॉनिक्स का भी स्टार्ट हो जाएगा.
ठीक है सर.
ठीक है?
Yes, sir.
तो अभी आपको सारे क्लास अटेंड करने हैं, अपना नोट्स प्रिपेयर करना है. जो डाउट क्लियर नहीं हो रहे हैं वो आप डाउट मुझसे डिस्कस करो और क्लास टेस्ट देते रहो. पहला स्टेप यही है. अगर ये स्किप करोगे तो ये 6 मंथ के बजाय ये 1 ईयर 2 ईयर प्रोग्राम में चेंज हो जाएगा. सीरियसली अगर आप 6 मंथ करोगे तभी जाके आप परफॉर्म करने के मोड में आओगे.
सर
है कि
क्लास
नहीं?
टेस्ट तो हर सब्जेक्ट का होगा. क्वांटम
सारे
मैकेनिक्स.
टॉपिक्स का होगा, जो नहीं भी हुआ है वो भी होगा.
सर
ठीक है?
थर्ड स्लाइड सर.
लास्ट स्लाइड,
थर्ड स्लाइड.
थर्ड. ओके. ठीक है?
Yes, sir.
चलो फिर कल मिलते हैं.
सेकंड स्लाइड सर. Sir, VCVS means?
means I told you voltage controlled voltage source. C for current. So voltage controlled current source, current controlled current source, current controlled voltage source. ठीक है? Clear?
Okay, sir. Thank you.
Okay. Thank you, everyone. Thank you.
Thank you.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.